So anyone who is aware of the term glancing angle? In reflection, anyone who is aware of the term glancing angle? Anyone? पता है या नहीं पता? The angle made by the incident ray with the surface of the mirror is called glancing angle. The angle made by incident ray with the surface of the mirror is called glancing angle. Now mention about real and virtual image. Real and virtual image. An optical image is a point where rays of light either intersect or appear to intersect. The image of an object is an assembly of image points corresponding to various points of the object. Corresponding to various points of an object. If the rays after reflection or refraction actually converge at a point, the image is said to be real. And it is not only to be seen, but also obtained on a suitably placed screen. If the rays do not actually converge, but appear to do so, and actually diverge, the image is said to be virtual. A virtual image can only be seen and cannot be obtained on a screen at the position of the object, at the position of the image. Now, what is to be done? You have written a paragraph on real and the virtual image. Whatever you have written, check out with that figure, whether it is written properly or not. If you are coming across new words, you should be able to raise the question about it. What does that mean? Okay? Converge. They are coming together, you say that it is converge. If they are moving away from each other, then it is known as diverge. Okay? So if suppose you are able to see that all the rays are coming to the point, suppose not in this figure, all the rays are coming to the point, then this is the part which you call it as converge. And the point is here, but the rays are moving like this, then you call it as diverge. This can also be drawn in this manner. This is one ray. This is known as diverge. Here, the rays are appearing to be coming from this point. So that is the meaning of converge as well as diverge. Okay? So any other question, any other word? Now what you have to do, you have to read a paragraph, look at the figure which we have already drawn and check out whether in accordance to that figure the write-up has been written or not. Read the paragraph, compare it with the figure. Do you agree? Now this point is extremely important because later on you are going to come across number of situations where you will be asked about the image, whether it is real or virtual. So about that it is clear. We have already made the point erect as well as inverted, that is clear, and magnification. So we will be talking on these lines, so you should be clear about when to call it as a virtual image and when to call it as a real image. Okay? Real images will never be seen by you directly unless and until you take it on a screen. Remember it very well. Just now we had a solar eclipse. It was not seen from India. But in Europe and USA, you were able to see the solar eclipse. So they make a pinhole camera. And that pinhole camera can be used to find out the image of the solar eclipse. You cannot see the solar eclipse directly with the naked eyes because it will burn the retina, it will have some complications created in the eyes. So what we do, we take the image on the screen, on the wall, or on the some cardboard, and we try to see it. Right? So that part, we are calling it as a real image formation. Normally, the real images are inverted. But as the sun and the moon both are spherical in nature, will the inverted image be seen by you as inverted? Because both being sphere, you will see that it is only the sphere. So that part is to be remembered. Okay? Is it clear now? Okay. Now there is something called as angle of deviation. Are you aware of that? Sure? What do you mean by deviate? You are having a plane mirror. The ray of light is shown to be incident on a plane mirror along this path. If mirror would not have been there, the ray would have moved along this direction. So this is representing the original path of the ray. Original path of ray. At this point of incidence, we will have here a normal drawn. This is representing the incident ray. This is representing the angle of incidence. by laws of reflection, it will obey the same angle as the angle of incidence, and angle of reflection will be same. So you will be able to see that the reflected ray will be traveling along this direction. Now from the original path here, the ray finally is going onto this side. So this is representing the final direction of the ray. Final direction of the ray. And this is the original path of ray. So from original path to the final path, this angle here, we call it as delta. That is called as angle of deviation. So from the geometry of the figure, it is written that I plus R plus delta is taken as equal to 180 degree. Can I write down this as the first relation? Right? Similar property have you seen somewhere? In geometry? Loudly. Triangle, very good. Sum of all the angles of the triangle is also 180. So sum of angle of incidence plus angle of reflection plus angle of deviation, that is taken as 180 degree. But we want to find out angle of deviation, so I will be able to write down this angle of deviation here, delta, to be equal to 180 minus of I minus of R. Can I write down delta to be equal to 180 minus of twice I? Can I write down delta is equal to 180 minus of twice R? You are having your reason provided, angle I is equal to angle R. If angle of incidence is equal to 0, then angle of deviation am I right? Am I right or not? Or there will be another solution for it. If angle of incidence is equal to 0, angle of deviation will be 180 minus 2R. That will be the second solution. Come on, say. No. Because if angle of incidence is 0, angle of reflection will be also 0. So 180 minus 2R will be 0 only, 2R will be 0. So you will be having 180 only. Nahi? So when you are writing angle I equal to 0, angle I equal to 0, it means that angle R is also equal to 0. So delta will be again equal to 180 degree only. What will be the angle of deviation if no reflection takes place? Hello? Loudly. So angle of deviation will be 0, right? So if there is no reflection taking place, angle of deviation will turn out to be equal to 0. Okay? Got it? We'll work more on angle of deviation. This is the basic of angle of deviation that has been demonstrated to you. We'll be working soon on a condition that will allow us to find out angle of deviation for multiple mirrors. So we'll work on that later on. This is the basic part of it. Okay? angle of deviation if there is no mirror or there is no reflection. So it will not change the path, it will be traveling along the straight line, so there is no deviation at all. So delta will be taken as 0. You are given a new situation here. There is a point object, and that point object is moving towards the mirror with a velocity u, where u is standing for velocity of the object. With what velocity image will be moving towards the mirror surface? Same means same means so that is why if you mark the answer here as u, your answer will be going wrong. If you mark the answer as minus u, then your answer will be correct, because whatever direction you are considering, in the opposite direction the image will be moving. Got it? I am again reframing the same question. What is the relative velocity of image with respect to the object? What is the relative velocity of image with respect to the object? Loudly. 0? You said 0, no? Okay, no problem. So are you aware of concept of relative motion? Have you studied the relative motion? So after eating the food, when the relative is going to make you bye-bye, then when they are in motion, it is called as a relatives motion. Are you aware of relative motion, yes or no? So what do you mean by relative motion? Can two vehicles be in a motion but still can be in a state of rest? Example? Or you are traveling, you and your friend is traveling in a train, then both of you are moving, but relative motion is 0. With respect to you, your friend is at rest. With respect to the friend, you are at rest. So that is called as a relative motion. Am I right? So in this case, I have asked you the question, what is the relative velocity of image with respect to the object? To you? Minus to you, u, 0. Easily the options could be generated, and these options are really important, how you are going to answer it. What is the relative velocity of object with respect to the image? What is the relative velocity of image with respect to the mirror surface? What is the relative velocity of object with respect to the mirror surface? If mirror is moving with the velocity v towards the object, then what will be the relative velocity of image with respect to the object? I am creating more and more complication when I am giving you different questions related to it. Yes? I think I should frame a question, you should write a question, and you should then answer it, and we will discuss it. That is the better part, because there are a number of possibilities here. Okay? So the question is, first one, related to the situation given there. You are having the mirror at rest. In the given situation, mirror is at rest and object is moving towards the mirror with a velocity u. Write down the first question. What is the velocity of image? Velocity of image with respect to the mirror surface. Leave a little bit of space and write down the second question. What is the relative velocity of image with respect to the object? Leave a single line, that would be sufficient. Third question. Second question I am repeating, what is the relative velocity of image with respect to the object? Second question only I have repeated. Third question, what is the relative velocity of image? What is the relative velocity of object with respect to the image? The fourth question, if mirror is moving with velocity v, if mirror is moving with velocity v, towards the object, with a speed, if the mirror is moving with a velocity v towards the object, comma, what is the relative velocity? What is the relative velocity of image with respect to the object? Next question. If mirror and object are moving in the same direction, if mirror and object are moving in the same direction, with velocity small v and u, small v and u respectively, what is the relative velocity of image with respect to the object? Now there can be more number of questions, but I'll give you the last question. You can have the combination of such things there to have the number of questions generated. If mirror is moving with a velocity of light and object is moving with a velocity u in the same direction, then what will be the velocity of image with respect to the object? What will be the velocity of the image with respect to the object? You can see how different type of questions can be framed. I can frame more, but you should get an idea how we have to approach the problem. So anyone who can give me the answer of the first question, read the question and tell me what is the answer. We can discuss that. First answer is clear to you, it is minus u, because image is moving towards the mirror, object is also moving towards the mirror, object is having the velocity u, so mirror will be having, image will be having the velocity as minus u. That's correct. Minus u, have you got it? What about the second question? क्या प्रॉब्लम है? बट कंडीशन क्या दिया है? पूरा प्रॉब्लम पढ़ना पड़ेगा, आधा नहीं. क्वेश्चन तो पूरा पढ़ो. रीड द क्वेश्चन कंप्लीटली. एनीवन? I am asking you to read the question completely. उतना ही दिया है. Question क्या है? Are they moving towards each other or away from each other? So object is moving towards the mirror दिया है. बराबर है ना? The object is moving towards the mirror with a velocity u, and you are asked to calculate what? Relative velocity of? So actually you should remember here, velocity of image with respect to the object will be taken as velocity of image minus of velocity of object. Got me? So in this case you are having the mirror present here. This is the plane mirror. You are having the image traveling along this direction. The image will be traveling along this direction. If the velocity of the object is u, mirror is at rest, mirror is at rest. So in that case, the object image will be traveling along this direction with a velocity minus u. Okay? So when you are writing velocity of image, it will be taken as minus of u minus of u. So you will be having the answer as minus of twice u. Able to get it? अगर वही क्वेश्चन अगर ऐसा पूछा है, velocity of object with respect to image, so it will be taken as velocity of object minus of velocity of image. Now velocity of object is taken as u minus of velocity of image minus of u. So you will be having the answer as twice u. तो आपका आंसर ट्वाइस यू कब लेना है, माइनस ट्वाइस यू कब लेना है, दैट यू शुड बी क्लियर विद दिस पार्ट. बोथ ऑप्शंस विल बी देयर, ट्वाइस यू भी रहेगा, माइनस ट्वाइस यू भी रहेगा, तो यू विल बी एबल टू गेट द आंसर करेक्टली हियर. व्हाट इज द थर्ड क्वेश्चन? फोर्थ. ओके, थर्ड इज कवर्ड. ओके, फोर्थ. Mirror. So mirror is also moving along this direction with the velocity v, right? Right? Now what you should do, you should not do it on the same figure. You should redraw the figure. Otherwise you will not get for what question which figures are drawn. मैंने तो वहीं पे कर दिया. I did it at the same place. You should not do it at the same place. You should redraw this figure again. This should be redrawn again. Otherwise, you will get confused later on. Now, first important thing is that you should know what is the velocity of object with respect to the mirror. So, for that part, we will be writing here velocity of object with respect to the mirror will be taken as velocity of object minus of velocity of mirror. Because they are approaching towards each other, velocity of object is taken as u minus of velocity of image, that is taken as minus of v. So you will be having here u plus v. Because object and mirror both are moving towards each other. So in a way, I can say that object is moving towards a stationary mirror with a velocity u plus v. You have to understand, if you are looking at mirror moving towards the object and object moving towards the mirror, then relative velocity of object with respect to the mirror. When I say that relative velocity of object with respect to mirror, I am assuming the mirror to be at rest. What is the velocity of mirror? To the left. But by putting here minus sign, I am trying to tell you that this velocity is in this direction. So actually you will be able to have minus v to be directed in opposite direction. If v is directed here, then what will be the direction of minus v? Opposite. So for a mirror considered to be at rest, I am able to show you this situation that this is the relative velocity of object with respect to the mirror. Able to get it? So image will also be traveling towards the mirrored surface with the same magnitude, opposite in direction. So in that case, you will be having here velocity of image. Velocity of image with respect to object will be taken as equal to velocity of image minus of velocity of object. So velocity of image will be the same value. So it will be traveling to the left. So it is minus of u plus v. Minus of u plus v. So you will be having the answer here minus of twice u plus v. So this is the relative velocity approach which comes from your second chapter of 11th standard. Kinematical equation में के बाद में आता है ये part relative motion. So we are bringing in relative motion here to understand the object and image relationship. Now the relative velocity of object with respect to the mirror is u plus v. So I can think of mirror to be at rest and consider the object to be moving towards the mirror at rest with a velocity of u plus v. So image will also have the same velocity minus of u plus v. How many questions are remaining now? Which are those? So in that case, mirror and object are moving in the same direction. It means that you will be having u minus v as the velocity of object towards the mirror. Because when two bodies are in the same direction, relative velocity will be subtracted. So in this case, the velocity of the body with respect to the mirror would be u minus of v. Getting it? So image will also be traveling with the same velocity u minus v in the opposite direction. So in this case, velocity of image with respect to the object will be taken as velocity of image minus of velocity of object. So in that case, you will be having velocity of image. It will be u minus v in the opposite direction. So you will be having minus of u minus of v minus of u minus of v. So your answer would be minus of twice u minus of v. The figure will be appearing to you differently. You will be having the object here. Object, it is traveling along this direction with a velocity u. You are having here the mirror. And mirror is traveling along this direction with a velocity v. The value of u is greater than v. So you will be able to have the relative velocity of object with respect to mirror as u minus of v. तो figure के हिसाब से आपको ये सोचना है. You have to think by looking at the figure. No, that is the assumption. Otherwise, you will be able to have v minus u. Whatever is greater from greater, the lower value is to be subtracted. No, it will be given to you in the problem. By looking at the numbers only, you will be able to tell which is greater and which is smaller. उसके आगे? No, mirror is not at rest. In this problem, mirror is in a motion. मैंने वही बताया, if object is having a more velocity, this will be the solution. If object is having the lesser velocity, then v minus u will be taken. Yes. According to condition, the answers will be changing. What about the last question? Now in this case, as mirror is moving with the speed of light, the light from the object will never be able to fall on the mirror. Because mirror is traveling with the speed of light. So the light from the object to reach to the mirror, you will find that mirror has moved away. So image formation will not happen here. When you are able to obtain the image, when the incident light is getting reflected, then only you are able to see the reflected image. Now in this case, if a mirror is traveling away from you with the speed of light, then whatever light is moving from you onto the mirror, it will not be able to reach to the mirror. Because by that time, mirror will be further ahead. Let us put it in a number form. Suppose you are having the object moving with 1 meter per second and mirror is moving in the same direction with 3 into 10 to the power 8 meter per second. Right? So in this case, you will be able to observe that the time taken by the mirror, by the reflection to occur, I am assuming here that distance between the mirror and the object is 1 meter. It is not given in the problem. Just to explain it, I am taking the example. So what will be the time taken by the light from the object to reach to the mirror? So it will be 1 upon 3 into 10 to the power 8 meter per second. 1 meter divided by speed of light will give us the time. But in that time, the mirror is always moving ahead. If I assume that object and the mirror both are at rest, then definitely the image will be formed. But if mirror is moving with the speed of light, then the rays of light coming from the object will not be able to strike the mirror because mirror is moving with speed of light. Will there be an image formation? So if there is no image formation, we cannot answer this question. There is no question of finding the velocity of the image because image itself is not formed. Are you getting me? समझ में आ रहा है क्या? इमेज बनने के लिए कुछ तो समय लगता होगा. You can calculate that time. If the distance between the object and image is object and mirror is 1 meter, then the time required by the light from object to strike the mirror will be 1 meter divided by 3 into 10 to the power 8 meter per second. So it is 1 by 3 into 10 to the power minus 8 second will be required for the light from the object to strike the mirror. But if your mirror is moving with speed of light, so whatever light is emitted by the object, will it be able to reach to the mirror? Because mirror is also moving with speed of light. So it will never strike the mirror, so there is no reflected ray. As there is no reflected ray, you will be able to observe that. No image will be formed. Are you getting this type of questions here? Now, many times at the night in the sky, you are able to see the star and suddenly it disappears. You are looking at a star and it disappears. What does that mean? When did it disappear? The moment you are watching it? Long back. Yes, it has disappeared very, very long back. Because that particular star is supposed at a certain distance or at certain light years away from us, then it will take the last light, it will not be existing, but the last light will reach to us after some light years. And that last part of the light was seen by you and then it disappeared completely. But it disappeared probably millions of years ago. Are you understanding this part? Similarly, in this case, the light will not be able to produce a reflection, and that is why this problem was given to you. You should be able to understand under what condition it will produce a reflection, under what condition it will not produce a reflection. Okay? One more important thing, theories of relativity. This is all about relative motion. So theories of relativity are not applicable at the speed of light. So that point can be mentioned by you. Relative motion ceases to exist at the speed of light. The relative motion ceases to exist at the speed of light. Write down a point. If a plane mirror is rotated by an angle theta, the reflected ray will be deviated by or reflected ray will be rotated by, fill in the blanks. So got the answer? 2. So for what part you have got the answer? There are 2 questions in it. So you are having a plane mirror here. And a ray of light is incident perpendicular to the plane mirror. What will be the angle of incidence here? Angle of incidence kitna rahega? Angle of incidence will be taken as equal to 0. So reflected ray will be traveling along this direction and angle of reflection is also equal to 0. Okay? Now I am rotating the plane mirror by an angle theta. I am rotating the plane mirror by an angle theta. So this is the plane mirror's new position. This is a plane mirror. This is plane mirror new position. Right? I have rotated the mirror by an angle theta. Now we have to see what would happen here. So you will find that at this point of incidence, I'll be drawing a normal here. So that this will now become the angle of incidence. Okay? Now, if you look at it, when you were having this position of the plane mirror, angle of incidence was 0. Now, can I say that if the plane mirror is rotated by an angle theta, the incident ray has remained at the same place, but the normal has rotated by the angle theta? Because originally the normal was present along this direction. This is the new position of the normal. Am I right or wrong? So this will be the angle of incidence. So with the same angle of incidence, you will be able to show here the ray will be traveling along this direction with this angle also as theta. Because angle of incidence will be equal to angle of reflection. So original ray was directed along this direction. Original ray was directed, reflected ray was traveling along this direction. And now the reflected ray is traveling along this side. So by what angle it has got deviated? It will be taken as twice theta. Able to get how we have arrived at twice theta here? Getting it? Understand the figures properly. Now in this case, what is the angle of deviation? In this case, what is the angle of deviation? 180 minus? So original path of the incident ray was along this direction. So this angle from here to here is the angle of deviation. So it will be 180 minus of 2 theta, that is giving us angle of deviation. So when you are rotating the mirror by an angle theta, the angle of deviation is 180 minus of 2 theta. Have you got this? Got it? Now there is a problem to be solved by you. So write down the problem. a man of height 5 feet wants to see his complete image in the mirror, what will be the minimum height of the mirror required? What will be the minimum height of the mirror required? This is a problem given to you. The height of the man is given to you. What will be the minimum height of the mirror required to see the complete image? Who want to see that? So from a small mirror, if I am keeping a small mirror here, will you be able to see your complete image? From here to the toe. You can see the complete image. Complete image I am saying. Kaise? So should I say that 1 centimeter mirror is sufficient to see the man's complete image? So what is the minimum height of the mirror required? Come on, you know about the reflection now to certain extent, so you should be able to get the answer. It's on a verge of completion of reflection from the plane mirror. 5 feet. Look, even if you are having a 100 feet mirror, this fellow will be able to see in a 100 feet mirror also. I am asking you the minimum height of the mirror. I am not asking you at what position you should have a mirror hang there. What should be the minimum height of the mirror so that a man can see his complete image in the mirror? You can say 10 feet, 5 feet, 4 feet, I don't have any problem, but you should have some logic behind it. 5 feet? तो 10 feet भी हो सकता है ना, 10 feet का मिरर रहेगा तो दिखेगा ना उसको, तो फिर वो 2.5 feet भी हो सकता है, 1 feet भी हो सकता है, 0 feet भी हो सकता है. How can you say that 5 is minimum? हाँ, कंप्लीट इमेज देखने के लिए 5 फीट की जरूरत है क्या? सही में आप सोचो ना. बट व्हाट यू आर डूइंग, आई विल टेल यू, you are just looking at the height of the man and not thinking of reflection at all. That is a real problem. We are learning the topic of reflection, so you should look at some of the laws of reflection and work on it. You are not working, you are becoming judgmental. I told you today also that as if I am speaking to all the scientists sitting here and you are telling it 5 feet लगा लो, दिख जाएगा उसको पूरा. Come on, make the use of what you have learned. Draw the ray diagram. Without ray diagram, how are you going to answer that? Your object size will be taken as 5 feet. So why they are saying half time? Reason is always important. So what I said to you, you are not using the principles of reflection. The first important thing is that you will be able to have a man which would appear to you like this. This is the position where you are having the eyes. This is the top end of the man. This is the bottom. Right? Now, you have to place a mirror at any distance, whatever distance you want, you can place it away or closer. This is representing the wall on which I have to mount a mirror so that the man is able to see his own image. So you must consider the eyes as important factor. So if a man is having a height of 5 feet, probably 4 inches above, he is having the hairs above. right? So if I consider it as 4 inches here from the eyes, this is 4 inches, then this part from here to here, if the height of the man is going to be 5 feet, what will be this distance? Remaining distance kitna rahega? Eyes se yahan tak ka 5 feet minus of 4 inches. So 1 feet is 12 inches. 12 inches minus of 4 inches will be 8 inches. So this will be 4 feet 8 inches. Right? Now, what will be the particular top head will be traveling and will be striking this particular point and will be reflected from this part and will be moving in the eyes of the man. The angle of incidence will be equal to the angle of reflection. So this is the top edge of the mirror. Top edge of mirror will be required here. Right? Then second part, 4 feet 8 inches, the halfway of this will be 2 feet 2 inches, 4 inches. So this is 2 feet 2 inches, this is the bottom edge. So this particular distance from the eyes to this part is 2 feet 4 inches. So if you add it, it would become 2 feet 6 inches. That is 2.5 feet. Because according to the laws of reflection, the rays will be starting from here, from the feet, will be entering here. At this point of incidence, it will be reflected and will be entering the eyes here. So size of the mirror required for complete viewing will be half of the height of the man. So answer will be, ये आंसर पहले देंगे, हाफ करना इजी है. Now someone was saying to me that if I increase the distance, what would happen? Right? Now if you increase the distance, the angle of incidence and angle of reflection will be changing. But that will not affect the size of the mirror. What would happen if I, instead of going for these two, I take some another position of the mirror like this? This is the wall. Now again, I will be extending this top along this direction. The halfway line is shown here. So this will be extended to this point. The midway line here will be extended here. What will change? Angle is arc length upon radius. So arc length are going to remain constant. यहाँ का arc length जो रहेगा वो constant रहेगा. ये वाला arc length भी constant रहेगा. Change क्या हो रहा है? Radius change हो रहा है. तो angle of incidence and angle of reflection will be changing, but the size of the mirror will be remaining same. Are you understanding my point? If I bring the wall onto this side, what will happen? Angle of incidence and reflection will be increasing. Because radius is decreasing, angle is defined as arc length upon radius. Radius is less, angle will be increasing because arc length are constant. So it doesn't affect from where you are observing. The size of the mirror minimum required will be half of the height of the observer. Then only you will be able to see the complete image. Therefore, the word minimum is also important here. So nothing was there in this part. It was only the part of laws of reflection. Understanding some finer points that angle of incidence and reflection will change as the distance between the mirror and the man is increasing. But the size of the mirror would be required same. Have you got the analysis? Now write down one important point on the same lines. if you want to see a complete wall behind from the center of the hall the minimum size of the mirror required on the opposite wall is h by 3. Is h by 3, where h is the height of the wall. Now this is actually the hall. Suppose I am standing at the middle between the two walls here. Now if I want to see a complete wall behind on a front wall, I should mount a mirror of height h by 3, then from the center of the hall. Then I will be able to see the complete wall behind me. Are you able to get this point? So again, you have to make the use of laws of reflection, and you can verify it how this will be done. Here the position of object depends. Position of observer depends. Because if the position of the observer is changed, the height will be changing here. But in case of the first part of a man looking at himself completely in a mirror, the position of the observer doesn't affect. In this case, it will be surely affecting it because the size of the wall is fixed here. Able to get it? So, kaise situation have you got it? I am standing at the middle of the hall, observing the wall behind completely onto a mirror placed on the opposite wall. Then the size of that mirror required will be h by 3. You can make the use of laws of reflection to prove that point again. Okay? Now, it's actually a break time, but nobody is coming, is here. So, I'll just explain that part to you. Sin theta upon theta equal to 1. Should I explain that? Okay. Now, I have told you limit theta tending to 0, sin theta upon theta is equal to 1. This formula I have given you the day before yesterday, or yesterday only, in the earlier lectures, right? Now, can you find out sine of 1 degree from the log table? Something 0.174 is there. 157 or 174. Sine of 1 degree. You have to look at natural sines. 1 degree. 0.0175. So you are having here sine of 1 degree is 0.0175. Am I right? This is from the log table. Able to get it? Now what I will try to tell you here, that instead of having sine of 1 degree, I'll put down 1 degree as equal to pi upon 180 radian. Am I right? 1 degree will be taken as pi upon 180 radian. What is the value of pi? So value of pi is taken as 3.14 divided by 180 will be there. So you will be able to get this as 0.314 divided by 18. So I'll divide by 2 so that I am having here 9. 0.2 से divide कर रहा हूं तो 1 will be here. then 11, so it will be 5, then you will be having 7, right? So if I divide again, you will be having 0.0, 9 ones are 9, 67, 67 means 9 sevens are 63, right? Then 20 will be remaining. Can you say that these two values are approximately equal? Can you say that these values are approximately equal? So I can rewrite this relation as limit theta tending to 0, sine of theta divided by theta is equal to 1. I can rewrite this as sine theta is approximately equal to theta if theta is expressed in radian. Can I say that? Now you do one thing. You tell me what is sine of 2 degree. It will be 0.0349. I can write down 2 degree to be equal to 2 pi upon 180. 2 pi upon 180 will be pi upon 90. Pi upon 90 will be 3.14 divided by 90. So this is 0.314 divided by 9. Am I right? So if you solve it, you will be having 0.0327. 44 is there. So I will be having 4s are 36. 8 will be remaining. 8 is remaining there. So 9 8s are 72. Are the values closer? 0.0349 from the log table, and the value that I am able to get here is 0.0348. After that also I can calculate, because 72, 8 is remaining, so I will be having again 8 here. So if it is 0.03488, which is closer to 0.0349. So is the relation correct or not? Sin theta upon theta will be taken as equal to 1, provided that theta is very small. Right? Same is there with tan theta. Now take out the tangent table and tell me what is tan of 1 degree. Tan of 1 degree. कितना आ रहा है? सेम वैल्यू है ना? So sine and tan values are equal, provided that theta is very small and expressed in radian. So in physics, what we do, we don't write down this mathematical portion. In mathematics, you will be writing here limit theta tending to 0, tan of theta divided by theta is equal to 1. In physics, what we write down, if theta is very small, and expressed in radian, then sine of theta is approximately equal to tan of theta is approximately equal to theta. Where theta is expressed in radian. The same part of mathematics is directly written in this manner. Now what you need to do, you need to find out this relation is true up to what degree. 1 और 2 के लिए तो approximately equal है. For 1 and 2 degree, the values are approximately correct. Whether it is true for 3 degree, 4 degree, 5 degree, up to what degree this relation sine of theta will be equal to theta will be true. For example, sine of 10 degree, what is the answer? Sine of 10 degree. Sine of 10 degree as per the log table. 0. 17, right? Now sine of 1 degree is given to me 0.0175. I have done this calculation 0.0172. 10 डिग्री का होगा तो इसको मुझे 10 से मल्टीप्लाई करना पड़ेगा. अगर मैं 10 से मल्टीप्लाई करता हूं तो मेरा आंसर आएगा 0.172. Now you are able to see that the difference has increased. 172 और यहां पर आ रहा है 0.1736. यानी your answer has changed by 16, right? So as you go on for a greater and greater degree, you will find that the values are deviating from the value. Like sine of 20 करके देखिए. What is sine of 20? Sine of 20 कितना आ रहा है? 0.342. साइन ऑफ 2 डिग्री कितना निकाला हमने? 0.0348. बराबर है. इसको 10 से मल्टीप्लाई करना पड़ेगा. तो दिस इज 0.348. Now see the difference, 0.348 and there 0.3420. So difference goes on increasing. So up to a certain angle, preferably below 10 degree, the values are taken almost equal. Are you getting the part here? Getting it? We use this property in a refraction to a greater extent. And that is why I have given you this formula. And how it is to be done, you can check it out. Like you find out sine of 45 degree or sine of 50 degree for that sake. (0.7660), right? Now you have taken that part. Sine of 10 degree आपने निकाला था कहीं पर. ये 0.1736 है. इसको 5 से मल्टीप्लाई करके देख लो आपका आंसर कितना आता है. 17 5 65 के पास आएगा. 0.65 आएगा. It will not be equal then. So difference goes on increasing as the angle goes on increasing. So you need to have only that value which is for a smaller value of theta. So that smaller value of theta, if it is probably less than 10 degree, this rule can be used. Okay?